Hi everyone, welcome to my channel, Math Made Easy with Theory in 10 minutes. We're going to talk about basic trigonometric identities, okay? So it's very important that you review the previous video before coming here, especially to understand how to solve trig ratio for simple angles and multiple angles. So you need to know how to do that before coming to this video, all right? And like I always say, don't forget to like, share, and subscribe. And if you've not clicked the notification bell, I don't know what you're waiting for. All right. Now, what are trig identities? Trig identities are usually the equalities that involve trigonometric functions and they hold true for all the values of variables given in the equation, and they only apply to right angle triangles. And there'll be about 6 or so we're going to talk about in this video, because basically this 6 trig identities are what other identities are derived from. So basically the sine, the cosine, the tangent, the cosecant, the secant, as well as the cotangent. Okay. This video, I'm gonna focus more on the ratio trig identities and the Pythagorean trig identities. In other videos, I talked about the reciprocal trig identities and the other types of trig identities. Okay. So, because I'm aware some students do take notes from the video, so I'm going to write down what I just said. All right, so we have trigonometric identities are the qualities that involve trigonometric function. And hold true for all the values of the variables given in that particular equation. Okay, and also one of the things is that the basic trig identities only applies or holds through for right angle triangles. Okay, so the trigonometric identities hold true, or you can say only applies to right angle triangle. So only the right angle triangle that only applies to. So basically, if you remember, we talked about the right angle triangle in the previous video. So where I said one of the angle is at 90 degrees. So if, for instance, this is the angle you're considering, this here is going to be the opposite. Okay. The side, which is the longest side facing the right angle, is the hypotenuse. And the third side is the adjacent. So I've talked about this already in the previous video, okay? So, but there are about 6 trig identities that or let me say 6 trigonometry ratios that these identities are based on, okay? So I'm going to list the 6 trig ratios that the identities are based on. So basically all trig identities. Six trigonometric ratios. So number one is sine, number two is cosine, number three is tangent, number four is cosecant, number five is secant, number six is cotangent. Okay, so secant, cosecant, and cotangent. All right, so that. So that is the basic introduction to trig ratios. So there are equalities that involve trig functions, and they hold true for all the values in that equation. And this only applies to a right angle triangle, okay, and not to any other form as well. All right, so let's talk about the types of trig identities we're going to talk about. So the trig identities or trigonometric identities, so I call it trig identities. So there are several types. So the first one is what we call the reciprocal identities. Okay. So the first one is what we call cosec. Cosec theta is equal to 1 over sine theta. So the first one is cosec. The next one is sec theta. Sec theta is 1 over what? Cos theta. The next one is what? Cot theta is equal to 1 over what? Tan theta. So these trig identities, I've discussed these trig identities in other video. So all these ones I've discussed already in other videos. So please go back to the playlist and have a look at it, all right? So I've discussed this already. So I talked about the cosec, the sec, and the cot, but I'm just mentioning here just for completeness, all right? Now, the ones that we're gonna focus on the ratio trig identity. So we're gonna focus on the ratio trig identity. So we'll talk about tan theta, which is same thing as sine theta, divided by what? Cos theta. Then we'll talk about the concept of cot theta, which is the same thing as cos theta, divided by sine theta. Okay? Then the other one I'm going to add to this, I'm going to talk about the Pythagorean trig identity. Okay, so the first one I will talk about will be sine squared theta plus cos squared theta is equal to 1. And the other one I'll talk about sec squared theta minus tan squared theta is equal to 1. And the last one I will talk about will be cosec squared theta minus cot squared theta is equal to 1. So these are the three we're going to focus on. So I'm going to focus on these three, or these two, I beg your pardon. So I'll focus on this. Okay, I'll focus on this two. So because this is ratio trig identity and Pythagorean trig identity, these are the ones I'm going to focus on in this video. But other videos, I'm going to talk about the reciprocal trig identity. Now, just to make it complete, I'm going to just list the other types of identity. And the other types of identities I'm going to list now, I've talked about it in the advanced trigonometry video. So I'm going to just say here, but you don't really need to know it for this video series, but for the advanced, you need to know it. So I'm going to list them here. So the other trig identities, we have trig identities of complementary angles. And when I say trig, I mean trigonometric. Does that make sense? So trig identity of complementary angle. Okay. Then the other one we have the trig identities of supplementary angle. Then we also have sum and differences of angle. So all these have already been discussed in advanced algebra video. Then the next one we have double angle. Then we also have the half angle. Then we have product and sum. And we also have trig identities of products. All right. So these ones, we've talked about them already in the advanced algebra. Okay, so if you go to the advanced algebra playlist, all right, so you can have a look at them. So it was in the, I think, advanced algebra. No, advanced trigs, I beg your pardon. So advanced trig. So we've talked about this already in advanced trigonometry. So if you want to know more about these ones, please just go to the playlist and search for advanced trigonometry, the playlist, then you will see we've talked about all these already. So for this video, I'm just going to focus on the ratio trig identity and the Pythagorean trig identity. All right, so how do you go about this now? All right, as usual, I'm gonna state the rules on how to do this as well. Then we'll now start solving some examples on this. All right, so let's state the rules on how to solve Pythagorean trig identity or ratio trig identity. It does not really matter. How do you do it? So there are 5 rules or the 5 steps of doing this. So we have 5 steps. Or you can say 5 rules, no matter anyone that you prefer. So number one, the first thing you have to do is that you have to manipulate all the trig function so that the result in any is any of the trig identities. So it does not really matter. So basically we have about 5 trig identity that is important. So remember we talked about either the Pythagorean or the reciprocal or the basic trig function. So you'll see that the ratio trig identity we have, you can have to manipulate it so that it look like any of these 5. So you could look like sine theta over cos theta. So you change it to tan theta or cos over sine. So any of these 5 trig identities, you have to manipulate the function so it will have these at the end of the day. All right, so the first thing you have to do is to manipulate. So you have to manipulate all the trig functions. So as to result in any of the trig identity. Okay, so it could be either you do it so that you can get tan theta, which is the same thing as sine theta over cos theta, or you can manipulate it so that you can have cot theta, which is the same thing as cos theta over tan theta. Okay, or you can say the same thing as 1 over tan theta if you prefer that, or you can manipulate it so that you can have sine squared theta plus cos squared theta should give you 1, or you can have sec squared theta minus tan squared theta, which will give you 1, or you can have cosec squared theta minus cot squared theta, which is also going to give you what? 1. Okay, so after you've done the manipulation and everything, now number 2, what is expected is that you, in some cases, you have to ensure that you have the same trig function throughout the equation. So some questions that we'll be solving, you will need to apply maybe quadratic equation, or you need to apply a sort of a method to solve it. But the best way to do it is that you should ensure you have the same trig function throughout the equation. So in some cases, ensure you have the same trigonometry function throughout the equation. Okay, and after you've done that, You need to also keep in mind that you could solve some of this question, like I said earlier, using quadratic equation. So sometimes you could apply quadratic equation to solve some of this, okay? So in some cases, you could have, or basically you could solve the question. You could solve the question using quadratic equation. So in some cases, you might have to solve it using quadratic equation, but one thing you need to know is that regardless if you're using quadratic equation or you're using solving polynomials or depending the kind of trig equations you have, all the rules for solving trig equations for both multiple and simple angles will apply. So that's the reason why before you come to this video, you need to know, or you need to have reviewed the video on solving a trig equation for simple angles and multiple angles, because we're going to do exactly the same thing here, okay? So here, all the rules of solving trigonometric equation for both multiple and simple angles apply. So all the rules for solving trigonometric equation for both multiple and simple angles, they apply here, all right? Then one thing you need to do is that you need to be very creative. I don't know how to explain this, but you need to think very carefully, all right? So what usually happens is that sometimes a portion of the answer might not have a solution. So sometimes you might be able to solve in degrees, or you can either solve in radians. So, but you need to be creative. So at this point, you need to unlock your creative mind and try as much as possible to try to solve the question from a creative aspect. Okay, so that is the fifth rule. So this part here, you need to be very creative. Okay, so basically you have to think carefully. You have to think about the formulas. Okay, think about the reciprocal identity, or think about the identities you know about, and see how they play a role in what you're about to solve. So you have to think carefully. Okay, you have to think carefully, or basically be creative. Okay, so what you need to know is that what happens is that a portion of the answer might not have a solution. Okay, and sometimes as well, you can solve in either degree or radian. Okay, so these are the five things that you need to keep in mind. So you need to manipulate. In some cases, you have to ensure you have the same trig function. So the key word here is that you must have the same trig function. All right. must have the same trig function throughout the equation. Sometimes you might end up using quadratic equation to solve, okay? But you need to know how to solve multiple and simple angles, all right? And also another thing as well is that you have to be what? Creative. So those are the things you need to keep in mind while you solve all this type of question, okay? Good. Now let's pick some examples now and get to it. Let's pick some examples and get to it and see how we can solve them. So okay, so let's pick some example. Let's say we have this example here. We have 3 sine x is equal to 4 cos x, and the range is between 0 and what? 360 degrees. All right, so how do you solve this? Okay, so when you have something like this, what comes to mind first is that you should need to ask yourself, remember the first rule is that you have to manipulate all the trig identities, okay? So if you go back here, you need to think about, okay, how am I going to manipulate, because I have sine and I have cosine, what trig identity comes to mind? Now, if you look at this, the question we had sine x and cos x, and which of the trig identity have sine x and cos x? Now, if you look carefully, the only trig identity that do have that is what? Either tan theta or cot theta. Are you seeing it? So that means there's only two that have both sine and cosine. So now you have to then be creative. So how am I going to manipulate that question so that at the end of the day, I'm going to maybe have sine theta divided by cos theta, or I'm going to have cos theta divided by, oh, this sine theta, not tan theta. This should be sine. Yep. But how do you manipulate so that you have cos theta over sine theta? So now let's go back now. So now we know that let's try with the tan theta. So if you remind, just a reminder, okay, from that, we know that the only trig identity that have both sine and cosine is tan theta. So we know tan theta is equal to what? Sine theta divided by what? Cos theta. So we need to then manipulate this so that we can have sine theta over cos theta. So let's go. So we have sine x is equal to 4 cos x. All right. Now, what we can do, I can divide both sides by cosine. Okay, so let's go. So if I divide both sides by cos x, are you seeing it? So we're gonna have 3 sine x divided by cos x will be equal to what? 4. Now, but we know sine x divided by cos x is equal to what? Tan x. Okay? So that means before I change that, I can remove this 3 from here. So I can then decide to multiply both sides by 1 over 3. Are you seeing it? So that I can remove this 3. So this 3 now is going to cancel this. So we're going to have we're going to have this one now. We're going to have 3 sine x divided by what? Cos x will be equal to 4 over what? 3. But we know that sine x over cos x is equal to what? Tan x. So that will give you tan x is equal to what? 4 over 3. Now you can see that I've manipulated the whole initial question. I made it simple to tan x to be equal to 4 over 3. Now, But we don't just stop there. So you now have to, so it looks like a simple angle now. I remember I told you how to solve simple angle. We talked about it in the last video. So the next step is we then have to look for the primary angle or the principal angle. Then we now have to find the other angles within the range. Now, if you look at the question here, we're given a question in degrees. The range was in degrees. So that means we need to set our calculator to what? Degrees to solve here. So let's do that. So we're going to set our calculator now. So since we know that tan x was equal to 4/3, so x is equal to the tan inverse of what? 4/3. So the tan inverse of 4/3. So the tan inverse of 4/3, and when you press your calculator, it should give you 53.13 degrees. Okay? So it should give you 53.13 degrees. So therefore, okay, the principal angle. All right, so I've talked about all this when I was talking about solving simple angles, okay? So please go back and watch the video on that. So the principal angle, or you can call it the first angle, will be equal to what? 53.13 what? Degrees, okay? Now, when we are done with that, so what do you need to do then? We need to now find other solutions within this place, and we have tan. So please go back and remind yourself. So I told you using the cast diagram. So if you remember the cast diagram, just a quick reminder, I told you the cast diagram. So A, C, T, and S. So you can call it cast or you can call it act, depending on what you want to do. So I told you, how do you get the second angle for sine? Is 180 minus the first angle. Tan is 180 plus the first angle. Cosine is 360 minus the what? The first angle. We talked about this earlier. All right, so please go back and have a look. We talked about this, so you can now solve questions on it easily. All right, so let's move on quickly. So I'm going to use the same method I used in the previous videos. So I'm going to find all the solutions for this. So I told you the first thing to do to write down the first angle. So the first angle is equal to 53.13 degrees, right? The first angle is 53.13 degrees. Now, how do you get the second angle for tan? Now, the second angle is equal to 180 plus the first angle. So 180 plus the first angle, and that will give you 53.13 degrees, and that should give you around 233.13, and that is that. Are you seeing it? Then I told you that when you're going, what you do is that when you're going up, okay, in the negative x direction, because this is in degrees, you keep on subtracting 360, and you keep on subtracting 360 until you get to the minimum range. And the range in this question was what? 0 degrees. So we're going to keep subtracting until we get to 0 degrees, and then we'll stop. Then we also have to do, if we're going down in the positive x direction, we'll keep on adding 360, and we'll keep on adding until we get to the maximum range, which is what? 360. Then until you get to 360, and you what? You're going to stop. All right, so let's go. So we'll go in the positive x direction. So the third angle in the positive x direction is going to be equal to 531 degrees plus what? 360. All right. And this is going to give you around 400 and what? 13.13 degrees. You can see it is above 360, so we're going to not pick it. Yep, the fourth one as well is going to be above, but just for completeness, I'm going to just show it to you. So the fourth angle will be equal to 233.13 plus what? 360 degrees. And when you add it, it's going to give you 593.13 degrees. As well, you can see it's above 360, and you don't add as well. Now, when you're going up as well, the third angle, you keep on subtracting 360. So you start with the bottom one. So it's going to be 233.13 minus 360. And when you do that, it's going to give you minus 126.87. And you can see it's less than 0. You don't go. The same thing, the fourth angle in the negative x direction is going to give you the same thing, but we're just going to do it just for it to be complete. So the fourth angle is going to be 53.13 minus what? 360 degrees. And that will give us minus 306.87. As you can see, as well, it is not what? A solution. So therefore, the only correct answer for this is going to be 53.13 and 233.13. So all these are between 0 and what? 360. So the angle now, the x, so the x value that will be solutions for this is going to be what? 53.13 degrees and 233.13. Okay? And that is the answer for that. So that's how you solve the question, and that's how you know the value of x that what will satisfy this what trig identity. All right, let's pick another question now, number 2. Let's pick another one now. So let's pick this. So we have 6 cos squared theta minus cos theta minus 2 is equal to 0. Okay, and we're looking at it between 0 degrees theta and what? 360 degrees. All right. Now, this is an interesting one. So if you see when we went back to the rules, I told you that in some cases that you need to have the same trigonometry function throughout, step 2. And also step 3, I also told you that you can solve some question using quadratic equation. All right, so this is a classical example of that. Now, if you look at this, for instance, you have 6 cos squared theta minus cos theta, and that is minus 2 is equal to 0. Now, let's go. So we can solve this again. Cos squared theta is still the same thing as saying 6 cos theta all squared. Are you seeing it? Let me write the 6 better. So the same thing as saying, clean all this. So the same thing as saying 6 cos theta all squared. So cos theta and cos squared theta are exactly the same thing. Minus cos theta minus 2 is equal to what? 0. Now, so what you can do then is we can now say, for us to solve this, we can, to make it very easy or pleasant for your eyes, you can say let u to be equal to what? Cos theta. All right. So that means anywhere I see cos theta, I'm going to put u there. So it's going to become 6u squared minus u, okay, minus 2 is equal to what? 0. Now you can see we have a quadratic equation here, okay? So at this point now, I will advise that for those of you that have not go with quadratic equation, please go to my playlist and search quadratic equation, and you should see you should see I should have a complete series on quadratic equation. And I told you and I taught you how to solve quadratic equation. There are different ways you can use formula. You can use completing the square. You can use Wendy's method when a is equal to 1, when a is not equal to 1. You can also use factorization method, and there are different ways to solve this, okay? So I'm not going to talk so much about how to do it here because I assume we can all solve this. So what I'm going to use, I'm going to use Wendy's way here to solve this. So basically, I'm going to look for two numbers that when I multiply, it's going to give me minus 12. And when I add it, it's going to give me minus 1. Okay, because this a is not equal to 1, so it's going to be 6 times minus 2. That'll be minus 12. So that means I'm looking for two numbers that is going to give me minus 12. And when I add it, it's going to give me what? Minus 1, okay? So that means the numbers will be 4 and 3. So it's going to be minus 4 and 3. Minus 4 times 3 will give me minus 12, or minus 4 plus 3 will give me minus 1. And if you're not comfortable using the Wendy's way, you can use the formula, which is a minus b plus or minus square root of b squared minus 4ac divided by 2a, all right? You can use this method. And in this case, the a is going to be equal to the a is going to be equal to 6, the b is going to be equal to minus 1, and the c is going to be minus 2. So you can use this method as well. All right, so but like I said, I'm going to be using the Wendy's way to solve this. All right, so please feel free to use any method that you are comfortable with. All right, so here, so we're going to do it. So we're going to have 6u squared. So it's going to become minus 4u. Okay, 6u squared minus 4u plus 3u minus 2 is equal to what? 0. Now, what is common between both of them? We have to then factorize. So we have this to be 2u into bracket, 3u minus what? 2. And what is common here is plus 1 into bracket, 3u minus what? 2 is equal to what? 0. Now, the same thing, we have each of this, you bring out one of them. So we have 2u plus 1, and you have 3u minus 2 is equal to what? 0. Is that making sense? Then I told you that when you're doing this, you have to solve, right? Okay, so you have to solve. And so we're looking for u now, and you have to equate each of the bracket to be equal to 0. So we then have 2u plus 1 is equal to 0, and we have 3u minus 2 is equal to what? 0. Then we'll take 1 to the other side. So it's going to be 2u is equal to minus 1, and you divide both sides by what? 2. So therefore, we are going to have u to be equal to minus 1 over 2. The same thing, we're going to take minus 2 to the other side. So we're going to have 3u will be equal to what? 2. Divide both sides by what? 3. So therefore, the u will be equal to what? 2 over what? 3. All right, but you see, in this question, we are not looking for u. Understand? We're not looking for u. The question is asking us to look for what? X or theta, all right? So we're looking for theta, but we know that u, from the beginning, we made u to be equal to what? Cos theta, all right? So what we're going to do then is that we're going to replace the u. Now, we're going to replace that with cos theta. So we can now say cos theta is equal to 1 over 2. And we can now also say cos theta is equal to what? 2 over 3. Okay, so we have to replace it with theta because we're not looking for u. So we have to then solve this individually. All right, so we're going to solve this individually. So the first thing is that we're going to solve for cos theta and get all the possible answers for cos theta equal to half. Then we're going to solve for cos theta equals to 2 over 3. So this is something we've done already before. So that's why I said before you come here, make sure you know how to solve simple angles and multiple angles. So now we'll go to the same process. So now cos theta equals to half. So the theta, which is equal to the primary angle, will be equal to cos inverse of 1 over 2. Okay, the cos inverse of 1 over 2. Now let's go and check, are we working in degrees or radian? So if you look at the range between 0 and 360, all right, so I'm working in degrees. So you have to then set your calculator to degrees so that you can work on this. So when you press your calculator, this is going to give you cos inverse of minus half. Okay, this is minus half, should give you around 120 degrees. So therefore, the first angle or the principal angle for this solution is equal to what? 120 degrees. Then we need to now get all the possible answers for this 120. So as usual, we're going to have the first angle is equal to 120 degrees. Now, how do we get the second angle here? Now, the second angle, the same principle. Now, for cosine, cosine is 360 minus the first angle, right? And that will give you 360 minus 120, and that will give us what? 240 degrees. So we've gotten the first, and we've gotten the what? The second. So like I told you, when you're going up, you subtract what? 360. And when you're coming down, all right, and you add what? 360 degrees. All right, so let's go. So the range we have is in 0 and 360. So you keep on subtracting 360 till you get to 0 degrees. You stop. Then you keep on adding 360 degrees until you get to 360 degrees, and you what? Stop. So you can know that even if you add or subtract, it's going to be more than or less than. So, but just because I'm teaching a large audience, I'm going to show you how to get that. So now let's get the third angle now. So if you're going up now, the third angle in the negative direction, okay, will be equal to 240 minus 360 degrees. And this will give you minus 120 degrees. And this is less than 0, so it's not a solution. So you go for the fourth angle. The fourth angle will be the same thing. Will be 120 minus 360 degrees. And this is going to give us what? Minus 240, which is still less than 0. It's not going to be a solution. Now let's go to the positive direction. The same thing. The third angle, you keep on adding 360, will be equal to 120 plus 360. And that is going to give us 480 degrees. 480 is more than 360, so it's not a solution. And the fourth angle will be equal to 240 plus 360 degrees. And that is going to give us 600 what? Degrees, and 600 is not a solution. So for this then, the only correct answer here is 120 and what? 240. So that means for this, the correct values of theta is equal to what? 120 degrees and what? 240 what? Degrees. Okay? All right, so now let's go to the second one. Okay, let's go to the second one. So the cos theta is equal to what? 2 over 3. So the same thing, we're going to find theta. Theta is going to be equal to the cos inverse of what? 2 over 3. The cos inverse of 2 over 3. And you press your calculator because we're working in degrees. It's going to give you 131.81 degrees. So you set your calculators to degrees, all right? Then, when you do that, you now get your first angle. So as usual, we get the first angle. The first angle is going to be 131.81 degrees. Then the second angle So the second angle for this will be equal to, for cosine, is 360 minus the first angle. And this is going to give us 22, put this a bit more here. It's going to give you 228.19 degrees. So we've gotten the first angle and we've gotten the second angle. So as usual, when you're going up, when you're going the negative x direction, you minus what? 360 degrees. And you keep on minusing until you get to 0 degrees, which are the range. And if you're going the positive x direction, you keep on adding 360 degrees. And you stop when you get to the range, which in this case was 360 what? Degrees. So similarly, if you're going to add, it's going to be more than, but just because I'm teaching a large audience, all right, so I'm going to show you all the steps, what I'm trying to say. So let's start with the negative direction. So the third angle in the negative direction will be equal to 228.19 minus what? 360 degrees. And that will give you minus 131.81. So you see it's less than 360. So it's not a solution. Now, if you want to get the fourth angle as well, we'll give you 131. It's going to give us 131.81 minus what? 360 degrees. And that'll give us minus 228.19, which is also less than 0. And that is not going to be a solution. Now, if you want to also check in the positive direction, all right, the third angle, you keep on adding 360, okay, will be equal to 131.81 degrees plus 360, and that will give you 491.81 degrees. Is above 360. Then if you now go to the fourth angle, it will give you 228.19 degrees plus 360 is going to be above, and that will give you 588.19 degrees, and this will not work. So that means for this, the correct answer that should be between 0 and 360 is only 131 and 288. Okay? So that means theta here is equal to 131.81 and 228.19 degrees, all in degrees. Okay? Now, with that, now we can now combine the both answers. So we got this for this, and we got theta 120 and 40 for this. So therefore, we can now say for this question, the value of theta that is going to satisfy this is going to be 120 degrees, 240 degrees, 131.81 degrees, and 228.19 degrees. And that will be the answer for that. You see? So you see, straight to the point and easy. So basically, that's how you solve this question. So you have 6 cos squared theta minus cos theta minus 2 is equal to 0, and you solve it that way. Okay. Let's throw in one more question. We'll just throw in one more, or maybe two more for this. So let's throw in 2 more questions for this and see how we do. So let's pick this question here. Number 3. We have 2 sine squared x minus 7 sine x minus 2 cos squared x is equal to what? 0. And now we're looking at between 2 pi, negative 2 pi, x and 2 pi. All right. So remember, I told you that in the rules that the first thing you have to do, you have to ensure that they all have the same trig function, and you have to manipulate the trig identities as well. So now, if you look at this now, okay, we have sine squared, we have sine, and we have cos squared. Now, we can't work with two different trig identity in the same question, okay? So our best bet here will be to be changing the cos square x to sine, okay? So that's what we have to do. We have to change the cos square x to sine. Remember, we have to manipulate it so that everything in the question might either be a sine, or there'll be a cosine, or there'll be something else. We can't have sine and cosine on the same thing, so that in the same question. So that's the reason why you have to manipulate it. Now, but if you remember, one of the trig identity we have, okay, because we know that there's a relationship between cos squared and sine squared, because we know that cos squared x plus sine squared x equal to 1. So usually in some exams, they will give you a formula sheet, and in the formula sheet, we'll have all the trig identities. In some exams, they will just give you some and not give you all the trig identities, while in some, there's no formula sheet at all. So what I always advise students is that the more you practice questions, the more you solve, the more you get conversant and comfortable with all these trig identities. So from this now, we can now say, since we know that cos squared x plus sine squared x is equal to 1, we can take sine squared to the other side, okay? So it's going to give us what? Cos squared x is equal to 1 minus what? Sine squared x. So you can see cos squared x is the same thing as 1 minus what? Sine squared x. So what I'm going to do, I'm going to go back to the question and replace cos squared x with what? With 1 minus what? Sine squared x. So now it's going to become 2 sine squared x minus 7 sine x minus 2 into bracket 1 minus sine squared x. Are you seeing it? So now, since we have that now, we can now open the bracket to play around there. So we can now say 2 sine squared x minus 7 sine x. So remember, in basic algebra, I told you that when you have a, b plus c, you will use a multiplied by b to give you ab, and a multiplied by c will give you what? AC, when we're discussing basic algebra. So that is the basic thing we're also doing here. We're going to open the bracket now. So we have minus 2 times 1 will give you minus 2. Now minus 2 times minus sine squared x will give you plus 2 sine squared x. So remember I told you minus times minus is equal to what? Plus. While minus times plus is equal to minus. So we talked about this in basic algebra as well. So please, if you've not had a look, please go to the playlist and you will see that. So the next thing, we're going to collect like terms. So we're going to collect these like terms together. So we're going to have 2 sine squared x plus 2 sine squared x minus 7 sine x minus 2. So 2 plus 2 will give you 4. So it's going to give us 4 sine squared x minus 7 sine x minus what? 2. Now, if you look at this, like I always say, the best now you can see now that they will all have sign throughout the equation. And because we have sign now, we cannot apply the quadratic method we used earlier. So now we can also break this down, like I always say, we can break down the sine squared x. So sine squared x is still the same thing as saying 4 sine x all squared minus 7 sine x minus 2. Are you seeing it? So now we can now remove the sine x. So I usually prefer to not complicate it. So I'll remove the sine x and make it u so that it'll be easy for me to see. Then I'll return it back to sine x. So I'm going to say let u to be equal to what? Sine x. Okay. So that means we can now rewrite this down to be 4u squared minus 7u minus 2, and this is going to be equal to what? 0. Okay? So this will be equal to 0. Now we can solve this. Okay? We can solve this now. So you can use either any of the method, the when this way or quadratic formula or completing the square. But I'm going to use the when this way here. So let's go. So I'm going to look for two numbers that's going to give me, when I multiply 4 and minus 2, and that will give me minus 8. And when I add those two numbers, it should give me minus 7. So I'm looking for two numbers that I'll multiply, that will give me minus 8. And when I add it, it's going to give me minus 7. And it's going to be minus 8 and 1. So minus 8 times 1 will give you minus 8. Minus 8 plus 1 will give me minus 7. So it's going to give me 4u squared minus 8u plus 1u minus 2 is equal to 0. Okay? So like I said, you can use any other methods. I noticed that most students prefer quadratic formula. All right? So feel free to use it. Then you're going to look for, we're going to factorize this. So we have 4u is common here, and you have u minus 2. Okay. Now what is common between both of them is 1, and we have u minus what? 2 equal to 0. There you put it together, so it's going to be 4u plus 1. And we then have what? U minus 2 is equal to what? 0. Then as usual, we then equate each of them. So it's going to become 4u plus 1 is equal to 0. And we have u minus 2 is equal to 0. Then what you do, you take 1 to the other side. So it's going to become 4u is equal to minus 1, right? Then you divide both sides by 4. Okay? Then it's going to give us u will be equal to minus 1 over what? 4. Now, this one, you can take u to 2 to the other side, minus 2. So u is going to be equal to what? 2. Okay? But as you can see, we are not here to look for u, but we are here to look for x, right? So, but we know from the beginning that u is equal to what? Sine x. Okay? We know that u is equal to sine x. So we're going to go back and replace the u with sine x. So we now know that sine x is equal to minus 1 over 4. And we also know that sine x is equal to what? 2. So now the next part now is to get x. So x will be equal to the sine inverse of minus 1 over 4. All right, the sine inverse of minus 1 over 4. Now, we need to check. Are we going to be working in degrees or radians? So let's go and check. So we go and check. So if you see, if you look at the range was given in what? Pi, all right? So because the range was given in pi, we then have to work in what? Radian. Are you seeing it? So that means what you need to do is that you have to now go to your calculator and set the calculator to radians. Are you seeing it? So you have to set the calculator to radians to solve. So when you convert it to radians, so the sine inverse of -1/4, x is going to be equal to minus 0.25. So minus 0.25 radian. So this is in radian, all right? Now let's go and do it for the sine x. So x is going to be the sine inverse of what? 2. Now, when you press in your calculator, you will see that there is no solution. You get math error, okay? So that means there is no solution for that. So that means no solution. So that means you only have one solution here. But like we did in the simple angles, then this is going to move forward to get all the other possible angles for this. So that means x, which is minus 0.25, which is the what? The first angle. So we want to now see all the possible angles within the range of what? Minus 2 pi and plus 2 pi. All right, so you now do it. You know how to do it now. So the first angle is equal to what? Minus 0. What? 25. Now, how do you get the second angle now? So now you can see that in this case, we're working with radian, and it's going to be pi minus the first angle. And this is going to give you what? 3.39. Okay, so we've gotten the first angle, and we've gotten the what? The second angle. So as usual, when you're going up, you have to be, sorry, when you're going the negative x direction, you have to be subtracting what? 2 pi until you reach the lowest range of what? Minus 2 pi. Then you stop. And you need to be adding what? When you're going the positive x direction, you need to be adding 2 pi, and you stop when you get to positive what? 2 pi, which is the maximum of the range. So like I always tell students, I notice that some students struggle with radians. So I always tell them what you can do, you can convert this minus 2 pi in your calculator to decimal points. So minus 2 pi should be around minus 6.28. And plus 2 pi should be the same thing as 6.28. So what does that mean? It means that when you get to minus 6.28, you're going to stop. And here, when you keep on adding till you get to 6.28, then you will also stop as well. All right, so let's go. Now let's get the third angles in the negative direction. So the third angle, so remember we're going to be subtracting 2 pi. It's going to give us 3.39 minus 2 pi. And when you press your calculator for that, it's going to give you minus 2.89. Minus 2.89 is still less than minus 6.28, so you keep on moving. We go to the fourth angle. So it's going to give us minus 0.25 minus 2 pi. Minus 0.25 minus 2 pi. And when you press your calculator, it will give you minus 6.53. And it's less than that, so that means you stop here. Are you seeing it? Then we go to the positive x direction. The third angle will be equal to, you keep on adding 2 pi minus 0.25 plus 2 pi. And that will give you what? 6.03. 6.03 is less than 6.28. That is good. You keep on going. So you go to the fourth angle. The fourth angle is going to give us 3.39 plus 2 pi. And what would that give you? 9.67. 9.67 is greater than that, then you stop there. Okay. So you see that the answers you have minus 0.25, 3.39, and minus 2.28 are the correct answers for this. Okay. Also, 6.03. So that means the correct answer for x now, that our solutions will be what? Minus 2.89, minus 0.25, 3.39, and 6.03. And that's the answer for that. All right, so these are the values of x that will satisfy this equation here. All right, so what I'm going to do, let's pick one more question. Okay, so we're going to pick one more question, and that'll be that for this video in this series. So let's use this example here. So we have number 4. Let's bring it a bit down. So number 4. All right, so we have this, number 4. We're told that we need to prove, okay, we're told to prove that cos squared x divided by 1 minus sine x is the same thing as 1 plus sine x, and we have sine x is not equal to 1. Okay? So what they are trying to say here is that they want us to solve one part of the equation, and it should give you the other, it should be equivalent to the other part. Now, what I always notice is that some students usually prefer to cross multiply and do all those. No, you don't do that. So what they want you to do is that you should pick one side of the equation. So you can either pick the left-hand side or you pick the right-hand side. Then you solve that side of the equation, and the end of the day, it should be, your answer should be equal to the right-hand side. So for instance, in this example, I'm going to pick the left-hand side. So I'm going to pick cos squared x divided by 1 minus sine x. So when I finish solving this, my answer should be 1 plus sine x. Is that making sense? All right, so let's do this together now. So this is very easy, so don't feel as if it's hard. No. Now we can, remember I always tell you can always break things down. So if you remember, okay, if you remind ourselves, so you will see that I told you before that cos squared x plus sine squared x is equal to 1. Then if you take sine squared x to this part, so you know that cos squared x is equal to 1 minus what? Sine squared x. Okay? So cos squared x is equal to 1 minus sine squared x. So that means I can replace this cos squared x with 1 minus sine squared x. So that means I can now say that cos squared x over 1 minus sine x will be equal to 1 minus sine squared x divided by 1 minus sine x. Okay? So now also in basic algebra, okay, if you remind ourselves in basic algebra, I explained the concept of the difference of two squares. So why I told you, if you are confused, I think I labeled the video difference of two squares. Okay, so if you remind yourself of difference of two squares, so where I said a squared minus b squared is equal to a minus b and a plus b, all right? So we talked about this in that video. So, but if you look at 1 minus sine squared x, I can break 1 minus sine squared x like a difference of two squares, because this is the same thing as saying 1 squared minus sine x all squared. This is exactly the same thing. 1 squared is 1. Sine x all squared is the same thing as sine squared x. So that means applying difference of two squared, 1 is the a and sine x is the b. It is going to be equal to 1 minus sine x multiplied by 1 plus sine x. Are you seeing it? So because I know this now, then I can replace what I had in the beginning. So I had 1 minus sine squared x divided by 1 minus sine x. Okay, so now I can replace this now with, it will now be equal to, the numerator will be 1 minus sine x and 1 plus sine x divided by 1 minus what? Sine x. So this will cancel that. Are you seeing it? And my final answer will be equal to 1 plus what? Sine x. And this is exactly the same answer we're told to get at the beginning of the what? The question. Okay? So this is the same answer we're told to get at the beginning of the question. And we're also told that sine x is not equal to 1. So basically, when you are proving, okay, what is expected of you to do is that you just need to have one of the equation. Is that making sense? Have one of the equation, and then you try as much as possible to solve the left-hand side of the equation so that you can get the result on the right-hand side. And that's how you prove. And you usually do this, you use different methods. Some cases you have to use quadratic equation. Some cases you have to use basic algebra. Some cases you have to play around with polynomials. So different trig identities will have to come into play when you're solving proof questions. All right, thank you very much. And that is that for this video, okay? So the next video, we're gonna go into area and perimeter of two-dimensional shapes. So I will advise that you click on the notification bell so that when I post new videos, you'll be the first person to know. All right, thank you very much. I will see you soon. I'm gonna see you in the next video.